Assalamualaikum. I'm going to explain this example, leaching. Okay, you have the questions already. I guess some of you are having difficulty understanding this example. So this is leaching. So before this, just I want to explain you the basic concept. So you can see here what we have. We have feed. Feed in feed is solid, and then in solid you have two components: insoluble and soluble, which can be taken out. The solute is the soluble which can be taken out by solvent. So if you put solvent which is free of A and B, it can take solute, and that is called overflow, and we will have C as solvent there also. This is overflow, and then underflow we have slurry, the solid. Then some solvent can come here. Okay, and if the leaching is not 100% partial leaching, some solute also can come in underflow. You have feed, you have solvent. Overflow, we don't have in overflow, we don't have solid. Okay, there is no A, B and C only. And the important concept here is the concentration, or the mass fraction, mass ratio, which in this case we define based on solid free. So with this, when we say XB, this is basically B over B plus C. We don't include A. Okay, so XB will be in underflow, and Y we say YB in overflow. Overflow is free of solid. Okay, so YB will be equal to XB. So this is the important concept, like equilibrium. So they are in equilibrium, little bit in different way than what you have in other process like distillation, liquid extraction. But here, so YB equals XB. Okay, so let's come to the question itself. So we have feed which is having soybean. Okay, 100,000 kilogram per hour, with the B. B is the solute which can be taken by solvent. So solvent again 100,000 kilogram per hour. Pure hexane is, and then what we have, oil contained of flakes. Flakes means the in slurry underflow. It reduces to 0.5%. Okay, so basically what we have feed coming which has 19% of B solute, solvent. Okay, solvent will be free of B and A. Then what you have, overflow V and underflow U. Okay, so underflow, in this we have 0.5% of unleached oil. Okay, so in feed this is the one. Then insoluble, this is soluble 19. So 1 minus 0.19, this is the solid in feed we have. So initial, and then initial oil will be 0.19 times this. Okay, now we are interested to know how much we have here, or how much kilogram per hour the B will go there in slurry, in underflow. Okay, you can see here when we say this is the solid in insoluble, or solid in underflow. So now what this is, first of all, there's a mistake here. It should be 0.005. Okay, So when we say 0.5%, we mean 0.5 divided by 100, isn't it? So this becomes 0.005 over 1. So if you want, this is fraction. If you want to make a more the ratio, okay, what will happen? You need to, so 0.005, and then other one will be 1 minus 0.005, isn't it? So that's become 0.005 divided by 0.995. So if you, this ratio times the amount of solid, okay, or you can get it this one. How? in in underflow we have 0.5% of undissolved B, okay. So if total here is suppose x, so x plus, okay, so total is x, so x times 0.5 divided by 100. This is the unleased aisle will go to with the solid, okay, in the underflow. So this is 0.5%, right, plus the 8100, which is undissolved, this one, this one, and then that's become total x. So if you calculate this, you will get this amount, this. So this minus this become is this, okay. So total effective insoluble in underflow is this amount, kilogram per hour, okay. Now what we need to use this equilibrium graph which is given, okay. So we need to understand this graph. You can see what, just have a look on this and see what is xb on x-axis, mass solute divided by mass liquid, mass of solute which is B, okay, mass of solid divided by mass of liquid, XA. So underflow, as mass solute is increasing, underflow XA is decreasing in underflow, okay. And then you can see overflow. In overflow we don't have solid, in overflow we don't have solid, so XA is always 0. So this will be always at this level, no XA, okay. And then we need to find the feed and solution point. So this is the feed point, this is the solvent. As solvent we don't have a XA is 0, no A, only solvent, pure C, no B, so it starts with 0 0. Now the feed condition, at feed condition what we have, XB is the B is the solute, right. So XB will be at the feed condition B over always B plus C. So but in the feed we don't have C, isn't it? So C is 0. So XB will be always 1. So 1. Then what about XA or YA? Okay. So you can see the feed composition. So now YA, which is the solid by liquid. So total solid is how much? Total solid is this. So whatever which is not going to be dissolved, insoluble, this one unleached oil will be added as solid. So, and this is partial leaching, not 100% leaching. This solid plus this is this. Then liquid, total liquid is this. That is leached oil. So total oil minus unleached oil. So that is leached oil going to be in the overflow. Okay. So YA become this divided by this, which is 4.38. Okay. So now you can locate solvent and feed 4.38, and you can connect this one. Okay. And now we need to find the XB or YB. Okay. So as we said that YB here in the overflow will be same as YB here, XB in the underflow. So now let's get YB. YB is the kg per hour mass flow rate of B. This is B. And then total liquid. Total liquid B plus C. B plus C. C is the solvent. Okay. So YB becomes 0.157 or XB. So now in this we read it here and draw a vertical line up to this equilibrium line. So now what happens here? Underflow. In underflow we'll have this much of XA. Underflow we have solid also, right? So that's the ratio of the solid to liquid is 2.05, something like this. So this is mass ratio of solid to liquid. Okay. And then so this is so in overflow we have mole fraction, the mass fraction XB of this. Then basically we have to find the kg per mass flow rate of in each stream and the composition. Feed and S we know, then overflow and underflow. So total flow rate in here and what is the composition? So in overflow we have B and C. So you can see XB is this, then for sure the C is this 1 minus, there is nothing else, no solid there. This is done. Now in underflow we have XA 2.05. Okay, and XB same as overflow. XA XB is known. Now XA, you can see this is the ratio. This is the ratio mass or the mass fraction, total mass of solid divided by not total but the mass of solid to liquid. So how to change this? So this is this is the ratio 2.05 is to 1, isn't it? Ratio. So now in term of fraction 2.05 divided by total 1 plus 2.05. This become the fraction. So 2.05 divided by 1 plus. So this is the mass fraction of solid in underflow. Okay, so here we got how much mass fraction of solid is there. Now we should get mass fraction of liquid also, because this is case of partial leaching. Okay, uh, so now you can see this is the solid, and we need to know in solid, in liquid we'll have B and C both, isn't it? This is solid, then we have liquid. So liquid, what we have liquid now, 1 minus 0.67. This is liquid now. Okay, then in a liquid the fraction of B is 1.57. Okay, so in the liquid we have 0.157 fraction among liquid B. So we'll multiply with this and get this mass fraction. Total mass fraction is this B. Now mass fraction of C, yeah, you have B, you have A, you have A solid, you have B, the uh, solute, which is insoluble, and then total 1 minus. So this is done. Now we need to know how much the flow rate in the top and the bottom, in the overflow and in the underflow. So we will use the lever arm rule. You connect this one, this becomes M. Okay, mixture. Now this is overflow. So this is in reverse, right? So MV. So what we'll have, overflow U over V. Okay, so this is overflow. So this is overflow, right? And this is underflow. So opposite. Okay, so MV divided by MU. So 0.69, this is the 0.69 minus 0 and divided by 2.05 minus 0.69. 2.05 minus 0.6, this. So now we get the ratio of mass flow rate of underflow and overflow. That ratio is this: underflow and overflow. This is the ratio. Again, now from ratio we can get this, from it becomes fraction becomes like this. So 0.5 is to 1. This is the ratio. So total will be, this is suppose this is the underflow, so this is the overflow. So total what, 1.05, 1.51. Then you divide by this fraction, and this is the total liquid, which is solvent plus the leached aisle. Okay, so this is just giving you the distribution of liquid. This is distribution of liquid. So, and we know the total liquid is this. So 0.51 divided by, so this will give you the liquid flow rate in underflow. Okay, and we know the liquid. So total underflow is, this is liquid and this is solid in the beginning. Okay, so that's become this amount. Total overflow will be total in. we have F plus S. So both is 100,000, 100,000. So this is total in is 20,000 minus V. So F basically this is F. Sorry, F plus S equal to U plus V. So total overflow is V will be F plus S minus U. Okay, F plus S becomes 200,000. U is this. Okay. So we know total overflow, total underflow, mass fraction in each stream. Okay. So hope this is clear. And only thing total aisle recovery. So total aisle in the feed, how much aisle is percentage is recovered. So this is the total aisle was there. Okay. And then total overflow. So in the overflow we have this, and which contains B and C. Okay, which contains C is the solvent. Solvent will take the solute. So this times 0.157 is fraction of B. Okay, with respect to B and C. So this times this divided by this, which is 0.653. This becomes 65.3. Okay, so that's it. We calculated the flow rate, mass flow rate of V and U. What are XB, XC here, XA, XB, XC. Okay, and that's it. You have the solution already there. Hope it will help. Thank you.